Have you ever thought about what lies beyond the universe we know? Imagine for a moment if you set off on a spaceship, journeying endlessly through the cosmos. What would you find? An infinite stretch of stars and galaxies? A boundary that marks the end of space itself? Or something so incomprehensible that it defies all our understanding? These aren't just science fiction daydreams. For centuries, these questions have haunted the greatest minds in physics, and today, we're finally coming closer to answers that are both mind-bending and, dare I say, a little terrifying. Let's start with one of the fundamental mysteries of our universe. Why is the night sky dark? This may sound like an odd question, of course. The sky is dark at night. But think about it. The universe is packed with stars, galaxies, and massive clusters of light. If it were infinite and eternal, shouldn't the entire sky be as bright as the sun, filled with the glow of countless stars in every direction? This paradox, known as Olbers's paradox, hints at some deep and unsettling truths about the cosmos. To unravel this, we need to go back 13.8 billion years to the beginning of everything, the Big Bang. At this moment, our universe was born, not in a quiet, serene moment, but in a burst of unimaginable heat, radiation, and energy. Since then, the universe has been expanding, stretching space itself. Here's the kicker. This expansion isn't slowing down. In fact, it's accelerating. Imagine blowing up a balloon and watching it get bigger. Except this balloon is the fabric of space itself, carrying galaxies and stars further and further apart. The further away an object is, the faster it's moving away from us so fast. In fact, that some galaxies are receding faster than the speed of light. This expansion gives rise to a concept known as the Hubble spherical boundary around us, about 14.4 billion light-years in radius. Beyond this point, galaxies are moving away from us so quickly that their light can't reach Earth. Anything beyond this sphere is, for now, invisible. Think of it as an ever-expanding cosmic horizon that determines the limits of our observable universe. The shocking part? The observable universe is around 93 billion light-years wide, much larger than the age of the universe suggests, thanks to the rapid expansion of space itself. This boundary marks the edge of what we can ever hope to see, no matter how powerful our telescopes become. But here's the unsettling part. Does that mean the universe actually ends there? Or is there more? To figure this out, scientists turn to an old but reliable friend in physics, geometry. Einstein's theory of general relativity shows us that massive objects warp the fabric of space, creating gravitational fields. This concept applies on the grandest scales, affecting the shape of the entire universe. The universe could be shaped like a sphere, a saddle, or even be completely flat. Each shape offers different possibilities. In a positively curved universe, much like a sphere, you could theoretically travel in one direction and eventually end up back where you started. Think of it as the cosmic equivalent of flying around Earth. In a saddle-shaped universe, or a negatively curved one, space would keep diverging endlessly. And in a flat universe, space would extend infinitely in all directions, like a never-ending plane. So, how do we test this? Scientists turn to the cosmic microwave background, CMB, the faint glow left over from the Big Bang. By studying this ancient light, we can measure the angles of cosmic triangles formed by distant galaxies. If these angles add up to 180 degrees, the universe is flat. If more, it's positively curved. If less, it's negatively curved. The result? It turns out, as far as we can measure, the universe appears flat. But there's a twist. Even if it seems flat to us, it could still be curved on an unimaginable scale, thousands of times larger than our observable universe. Imagine standing on the beach. The horizon looks flat, but that doesn't mean Earth isn't round. Similarly, we could be seeing a tiny, flat patch of a much larger curved universe. So, what does this mean for the big question? Is the universe infinite, or is there an edge? The flatness suggests it could be infinite, stretching on forever in every direction. This has led to some startling implications. If the universe is truly infinite, then statistically speaking, every possible configuration of atoms should exist somewhere out there. That means somewhere, light years away, there could be another version of you, watching this video, but perhaps wearing a different shirt or making a different decision. This concept isn't just theoretical. Cosmologists have calculated that if you traveled a distance of 1 nonillion meters, an unimaginably large number, you'd likely find an exact duplicate of Earth, with all the familiar faces, but with slight, eerie variations. Here's where things get even weirder. Quantum mechanics suggests that particles don't have a single, defined position or state until they're observed. Instead, they exist in a cloud of probabilities. Applied on a cosmic scale, this has given rise to the idea of a multiverse, an ensemble of parallel universes where every possible outcome actually occurs. In one universe, you became an astronaut. In another, you're watching this video in a completely different language. This isn't just wild speculation. Many physicists believe that the multiverse is a natural consequence of the same mathematics that accurately predicts the behavior of atoms and galaxies alike. But let's come back to Earth for a moment. If the universe is infinite and possibly filled with countless versions of ourselves, why do we feel so isolated? The answer lies in the expansion of space. Remember the Hubble sphere? As it grows, more of the universe slips beyond our view. In fact, distant galaxies are moving away so fast that one day, even the closest galaxies will disappear from our sight, leaving us in an empty, dark void. Billions of years from now, future civilizations might look up at the sky and see nothing but darkness, unaware of the vast cosmos we know today. So have scientists solved the most terrifying problem in physics? In a way, yes. We've come closer than ever to understanding the structure, scale, and potential infinity of the universe. We've glimpsed the possibility of parallel worlds, infinite versions of ourselves, and the looming prospect of cosmic loneliness. But in solving these mysteries, we've only uncovered deeper questions, questions that hint at a reality far stranger than we could have ever imagined. The next time you look up at the night sky, remember, every star, every galaxy you see is just a tiny fraction of the grand cosmic puzzle. Somewhere out there, the universe holds secrets we can't yet fathom, answers to questions we haven't even learned to ask. And as terrifying as these mysteries might be, they are also profoundly beautiful, a testament to the endless curiosity that drives us to explore, to seek, and to understand. So, if you enjoyed this journey through the cosmos, don't forget to give us a thumbs up and share this video with fellow space enthusiasts. Your support helps us continue exploring the wonders of the universe. Be sure to subscribe to SPACEEFIED and hit that bell icon so you never miss an update on our latest discoveries. Let us know in the comments, what question about the universe keeps you up at night? The truth may be stranger than anything we can imagine, and that's what makes it worth searching for. Dive deeper into the mysteries of space by checking out our other videos, and let's keep the adventure going on together.